All right. Hello, my name is Thomas Hawkinson, and my presentation is on a PWM controlled 3D printed lantern that I made for making for innovation. So first for the overview and the objectives of my project. In this presentation, I'm going to talk about the circuitry and the PWM coding that I did for the lantern, um, the choice of materials that I've made, as well as the design of the chassis, and the assembly and component layout, and then I'll finish it up with the timeline for the course of the project. Uh, for this project, I wanted to focus on three objectives. The most important one is having a complete range of the control of the light. I wanted the lantern to be able to cover its maximum brightness spectrum and also be turned down till it's completely off with that knob. Um, I also wanted the chassis to be completely 3D printed. This is both for the sake of expedience to make the project relatively easy and quick to do, while also giving me the ability to design the chassis from the ground up, specifically for the components that I wanted to fit in it, as well as to give it certain features that otherwise I would have trouble implementing in one clean sweep. And lastly, I wanted parts to be easy to access and to replace. This one was important because since this is a prototype, things are going to break. It's more than likely that the way I'm going to do things is not the best way to do things. So I wanted to give the project growing rooms, so to speak, so that like if light bulbs burn out, I can replace them. If I find a better way to do the circuit that's more energy efficient or that has better heat dissipation, I can do that. If I decide I want more powerful or less powerful batteries, I can swap those out, basically to make the project more flexible long term. So first for the circuitry here, I have two 3.7 volt 18650 batteries. I've worked with these before for personal things, mostly just with like already pre-made flashlights. And I really like the performance that I got out of them, so I wanted to implement them into this project. Uh, the potentiometer itself doesn't directly control the brightness of the LEDs, but rather it acts as an input for the Arduino that controls the LED brightness. Since LEDs are either on or they're off, the only way you can really control the brightness is through pulse width modulation, which is done through the Arduino. I also had to work with some new components for this project, such as a MOSFET. Since Arduino Nanos have a hard limit with how much voltage they're actually able to produce, since they're made more for signals than they are for actually providing power to a system, I had to find a way to use the Nano to control something that could handle that extra power from those two batteries. So the MOSFET was how I did that. All the lights are connected in parallel because otherwise they wouldn't all get bright enough to really meaningfully work as a lantern. Over here in this picture, you can kind of see what the maximum brightness looks with the test circuit that I made. Uh, and you can see like how drastic the shadow is on the back of the wall. It lights up the whole room quite well. I'll demonstrate that later on in the actual demo of the project. I think that's about it for the circuitry. For the Arduino itself, I have the code up here in the top right. Uh, I'm not going to explain every line of code here, but I'll go through basically how it works. But first, before I do that, the reason why I chose an Arduino is because I actually lack a lot of experience with Arduinos, and I feel like it was kind of a hole in my education since I know how versatile they are from seeing projects online, and I wanted to make myself more familiar with that so that in the future I'm more comfortable with using them for my own personal projects. And I saw this as an opportunity to improve my familiarity with them. And since I already had an Arduino, it was also an opportunity to save some money on materials since I can reuse my Arduino for this project, which saved a little time and money too. So the two big things to focus on in the code are the analog read and analog write lines that are down in like the early teen rows here. Um, and those are the lines that are used to control the PWM frequency. The analog read basically picks up the strength of the voltage signal coming from the potentiometer and then scales that to the frequency that's used for the pulse width modulation. The greater the voltage that it receives, the brighter the longer the on stretch is for the pulse width modulation signal, the more power go the more time is spent sending power through the LEDs. and therefore it makes the LEDs effectively brighter. This A0 on the Arduino Nano here in the circuit diagram is the input from the potentiometer, and then the output is D9 here, which is the pin that's kind of the default for working with PWM signals. For my material choices, I have two different materials for the chassis. The first is just regular old PLA. I just picked it because it's lightweight, it's durable. I've worked with it before for other projects, and I have ready access to 3D printing. I'm in a fortunate spot where I was able to make all of the chassis components next door at Kiewit Hall because I live in the courtyard, so it's just across the street from me. And for resin, I've never actually used the resin printers here before. I've never used SLA printing, so that was something completely new I had to work with. But overall, I'm really happy with how that turned out. I learned a lot from it. Resin was chosen primarily just because you can 3D print with clear resin pretty easily. 3D printing with PLA didn't really look as good when I asked people about it, like which one I should pick, and they suggested that resin would work a lot better for light dissipation, so that's what I went with. There are a lot of translucent options with resin. I kind of went over the other points here already. One thing that of note with the resin that I didn't think about is that resin is much denser than PLA, which luckily ended up not being a problem for this project because I made the base wide enough that it's not really likely to tip over. Even if it is a little top heavy, it still stands up just fine. It's still very stable. But if I'd made this more narrow, that would have been something that I probably would have had to redesign for. Luckily, that extra weight didn't end up being a problem. So for the chassis design, I went over a couple of these points already. Um, the base is oversized on purpose for stability purposes. I added a the dome itself is rounded off to improve the light dissipation. If it were just flat, then it would mostly be a flashlight just pointing directly up. Then it would be an actual lantern that illuminates an area. So I rounded off the edges of that, and I wanted to do some frosting to the light dome, but I ended up not needing to because after I printed the resin parts off, before I even like tried to like do any sanding or anything to make it less glaring to look at, it kind of handled that on its own. The sanding that I did from all of the dovetails and such, and just working with the material ended up maybe even just part of the curing process ended up frosting the texture enough that it's fairly comfortable to look at even when it is fairly bright. Um, I also added a notch here in the handle. That's for hanging it from a hook from above. So that way, like if you're camping in a tent and you have like a tent pole or a hammock thing inside the roof of your tent, you can hang the lantern up in there instead of keeping it on the floor where it might get wet. Or if you're working in a dirty space and you want to hang it on the wall or something like that, you can do that, and then you don't have to worry about the handle sliding around as it's like moving about. Uh, and overall, I think it was a really nice feature to add, even if it was only a small detail. The controls are just on the side of the lantern. I have a simple on-off switch here, and then the potentiometer controls the signal to the Arduino, which controls how bright the lantern is. These are the only two controls that I have here. For the component layout, this is kind of what the guts of the whole thing looks like. I have the two batteries in the bottom here, which I designed in a way that you can swap out the batteries without having to take apart the whole thing. You have to slide off the bottom, but otherwise you don't have to do any unplugging. You don't have to like mess with the circuit at all. It's fairly simple. You slide out the bottom, you replace the batteries, you put them back in, close it up. It's a simple, quick process. The middle section contains most of the circuitry. I ended up soldering the potentiometer and the light and the on-off switch, but the rest of the circuit I just stuck with a breadboard, mostly for the sake of making it easy to swap parts and also to upgrade the circuit as needed. It makes it look kind of like a rat's nest because it is. I decided to live with that because I wasn't able to really source wires that worked very well, worked really well with the breadboard. So instead, I just kept them as is for the sake of making sure that I actually had a prototype that worked properly. Um, I tried stripping them off and shortening up the wires, but the wiring itself was too thin. It couldn't grab onto the inside of the breadboard very well. So the circuit just if you knocked it around, it wouldn't have stuck. So I ended up just scrapping that idea and keeping it ugly like this because even though it's ugly, it works. Um, The resin parts act as the LED housing. Anything that the LEDs need to have light pass through, I made out of resin. So that disc part where they're attached here, that's resin. The dome that goes over the top, that's resin. I already went over the breadboard here. The LEDs are also connected to a chunk of breadboard for the same reason. It's because LEDs die. If I want to put nicer ones, or I want to hook up a proper like lantern emitters to it to improve the reliability, I have the option to do that. And if these burn out, they're only a couple cents to replace. Well, not a couple cents, a couple dollars to replace. So I buy a pack of those, swap out the dead ones, put new ones in. Quick, simple, easy. And now for the assembly and the post processing, this was probably the most challenging part of like the finished product. I would say like the circuit design was tricky, but this is the big thing that I wasn't expecting to be difficult that I ended up having the most problems with. Uh, Luckily, most of the issues I ran into were not serious. Um, Most of those issues just had to do with like sanding down the resin parts. I'd never worked with resin before. I've never worked with SLA printing, which means I was pretty unfamiliar with its properties, as well as what sort of post processing I needed to keep in mind with it. Uh, which meant that like after like it was already printed and I had to cure it, I didn't consider how soft the material was, so that led to some light deformation in the material before the curing process. After the curing process, I missed some of the supports that were used in the SLA printing, which means that when I was trying to fit the parts together, things were rubbing in a way they weren't supposed to. And since I never worked with it before and it's clear material, I didn't notice those supports in the way. And that led to me sanding down some parts more than they probably needed to, until eventually it chipped a little bit. I got a little scared. I'm like, oh no, do I got to reprint this thing and throw off my schedule? But it ended up not being a serious issue and it still closes just fine. So I was able to just keep using this part. Um, Once I noticed that those supports were they were along like the outside rim, like between the two resin pieces. But once I noticed those and I was able to sand those off, it slid together very nicely and actually had much better tolerancing than the 3D printed components, the plastic components, I should say. Uh, which I think is just because of a difference in the precision of SLA printing versus 3D printing. I think that's about it. I did have some loose tolerances that were really easy to fix with just by putting bands of tape around it. Since the dovetails do take most of the vertical weight when you're holding it, it doesn't take a lot of force to actually keep the pieces in place. So just putting a simple band of clear tape kept it all very rigid. Nothing rattles around. Like I have it here with me. I don't have the tape on it so that I can show the components. Um, but when this is taped up, it makes no noise. You can throw it around, throw it upside down. It's great. I'll show that in the demo. Lastly, for the timeline here, this is kind of like how far back I went with the development of this, making sure that I could get it done on time, because that was probably the biggest challenge overall with this project is making sure that I didn't do it last minute and end up really, really hurting myself those last couple busy weeks of the year. I'm really proud of how quickly I was able to get on top of this, and I actually didn't have to crunch at all for it. As of right now, this presentation is the last thing that I'm doing the day that it was due. The due date was just moved, but I had this day planned out like 3 weeks ago, and I'm really happy with how well I've been able to stick to this timeline. But this is sort of a breakdown from my development log in the report. I started at the start of April here with just planning out the project. When did I want to have everything done? When was the soonest that I wanted to start the report? When was the latest that I wanted to have the 3D printing done? Because those last couple of weeks of the semester, everyone wants to use the 3D printers. So I knew if I wanted to have this done on time, that had to get done before those last couple of weeks, which luckily I was able to do. Uh, so that's kind of what happened on April 2nd. April 6th here, most of the circuit completion. I showed the circuit earlier and its brightness and how it works outside of the lantern. Those pictures are from this period of time. That's what I was doing is just getting a circuit put together that actually works and developing it. The design I worked on a few days later, April 9th, it looks like. That was mostly just planning what materials I needed to use, deciding if I needed to do PLA print, if I wanted to use PLA, if I wanted to do SLA printing with resin, with clear resin, or if I just wanted to try to find like a clear material I could use with a regular 3D printer. Ended up going with the resin. Uh, And then on April 18th, I did chassis assembly. That's when I made all of these parts here. Like the resin parts, that was the last day the resin parts were done. That was when I did I think the plastic parts were done by then, but the last of the printing was done. Um, was done that day. That's when I completed the assembly and put the circuit together too. So the project was basically done on April 18th. And then April 22nd is when I actually had the thing completely functional, no issues. Made sure to like work out any kinks with it, just basically just making sure everything fits together properly and that the circuit and that the lantern can be on for an extended period of time without anything overheating or causing problems. And it's also when I started writing the report. Overall, I'm really happy with how this has gone. So lastly, conclusion, I was able to get all the objectives. The brightness control works flawlessly. I don't have any complaints there. It can handle being on for extended periods of time. I've tested this thing for like half an hour. It doesn't really care how long it's on. It doesn't really get hot. The Arduino it does get noticeably warm when it's running, but as long as it's able to passively cool itself, it doesn't have any trouble with that. And I've never had issues with it. Uh, the things I had to learn with this is I have never worked with an Arduino in this way before. I had very limited Arduino experience before this project. I also had no clue what a PWM was, so figuring out how to use pulse width modulation with an Arduino was really interesting. I've never worked with MOSFETs or any other kinds of transistors, so it was actually really fun learning how those worked, and I actually found it to be pretty intuitive once I figured it out. And I can see how useful those are now and how and why they were such a big change for the world when we started implementing them into computer science. Uh, and I've also never done SLA printing before, and all of these things added unique challenges to the project that ultimately I think made me a lot more well-rounded when it comes to personal projects or making things in general. Big takeaways I took from this was project planning. Again, like you saw my timeline, I started this over a month ago and had it pretty planned out, more or less week by week, back at the very start. And being able to stick to that schedule really helped me manage both this project and also everything else I'm doing. I think I had like 5 projects due during dead week. And because I was able to stick to this plan, I never had to worry about this project. So it's just been chipping at it a little bit here and there, and whenever I know I'm going to have time for it. And the result is that it paid off. This has been only a fun project for me. And I'm really happy I got to do it overall. It also taught me a lot how to prepare for problems last minute, like with the chipping problems I had, or worrying about like the Arduino having power issues, or like planning for parts failing, because I had to go through quite a few LEDs before I got this thing to work reliably. And now that I've gotten here, I feel like it's taught me how to adapt a lot when it comes to physical products like this. So overall, I think that's my presentation. I don't know if I'll add it to the end of this, but I'll include a demonstration of this lantern as well. But for the presentation, that's all. Thank you. Oh, oops, I'm still recording.